My name is Conrad Pinault, and I welcome you to our new tennis development webinar program. We'll offer you capsule on different topics to help your level of play. The capsule will be as for the single as for the double. We will cover the tactical, psychological, physical, and technical aspect. This capsule will aim to make you aware of the impact of science concepts on our sport. Having some scientific knowledge will surely help you in your game choices and in understanding certain mistakes. This content is applicable for all levels. Good viewing. Have you ever wondered how good players can keep the ball in the court by hitting above 150 kilometers per hour, when at time we have difficulty when we hit barely at 50? We will analyze some example and see how science explains these possibilities. Here's an example of Verdasco. He will hit a forehand on the run at 179 kilometers per hour. Notice how he will strike that ball on the run. That's another example of Murray, who will hit the ball at 199. He put his opponent outside of the court, forcing him to play a soft ball. He's going into the court, take the ball early, and finish it. And look again how he will do it. Look again. Here, Gaël Monfils with a shot here close to 200 kilometers per hour. He built his point cross court until the opponent gave him an easier ball, and still from the baseline he can hit the winner. And see how he's doing it on that shot. Boom. So how do we explain that some players can hit balls at that pace? What do they have in common? All of three, they're tall person. All of them jumped to take the ball at the contact. All of the three impacts, they were above the net. That gives them an angle a little bit descending in the shot because they are over the net. You have less speed limit on descending angle compared to the one who has to go up. Murray is the closest, so you have more angles. The three of them use a good mechanic. So we're gonna cover some here's the concept we're gonna cover. We're gonna see some mathematics concept, some physics, make the difference between the basic and the specific fundamentals for these capsules. We have to do some technical priorities. What we want to do with the ball and understand what body movement is needed to do with the shot. The ball trajectory is a priority before anything else. Here is an example of Federer, who will perform a forehand when he is receiving a deep ball. You will notice that there is a mechanic order to respect in order to have a good rhythm. We call that basic fundamentals. Let's see the same sequence on a video. We mean by biomechanic is to use all joint in the right order. That's why we can have some good rhythm. Use the proper split step. How to go with the first step. Rotate the whole body in the right direction. Arm position sideways in the direction of the ball before the ball touches the floor. Twist the articulation using the bottom and the legs. Drop the racket head and be sure you rotate at the impact. Everything is almost facing the net. Body still rotate after the impact, and you are using a step to recover after. All of these mini articulation has to be done in the right order. We will have specific capsule to go more in details in these kind of things. But obviously, the three guys, they have that common point where they move the right articulation in the right order. The specific fundamentals is what the ball does. The specific fundamentals, it's make the little small adjustment to make the control on the ball. It is possible to move all articulation and still missing the ball. We can receive and throw the ball on with different height, different speed, different direction, different spin, different distance. We will go into much detail in other capsule to understand the specific biomechanical fundamentals. For now, we'll focus on how to use some scientific concepts to improve our game design. To begin, we need to understand the analysis of the ball trajectory from different angles. The motion analysis of a projectile will be useful if we have some physical basis. Let's see, for example, different ball trajectories by varying some ball's control. Let's imagine hitting a shot from the baseline at the height of 50 centimeters from the ground, and that shot is played without spin. The shot was hit at 127 kilometers per hour above the net. You will notice the speed limit to be met per meter projecting over the net, so that ball can stay within the boundaries of the court. Now, imagine the same situation if we always hit the ball at the same speed, but projecting the ball at different height. You will notice that the different distances reached is when we throw our shot at an angle of 45 degrees, then the ball will go further. However, you should know that when you throw the ball above 45 degrees, you can gradually increase the speed. And it will be possible to play the same speed as the ball near the net if we throw the ball at 85 degrees. Certainly, the height will be affected. Now, another scientific concept is the angle of incidence and reflection. The concept of optical physics is essential in understanding how the ball can emerge from our racket according to its origin. Like the ray of light in a mirror, the ray will come out in the same angle as it will come in. We'll have to compensate with a few technical points to control the ball trajectory. So let's see this example. Imagine when you are moving at the net and your opponent is trying to pass you cross court. Your best choice will be the down the line volley, but your shot is flying into the corridor. What happened? That's exactly what this legislation does. There will be some option to ensure that the ball can follow our intent, either by changing the angle of your shot, by changing the impact, or by the angle of wrist. You can also modifying your speed to neutralize the receive angle ball. Changing the direction of the ball is really complicated, and that's why if you decided to play down the line when you receive a cross-court situation, even if you are at the baseline, you need to consider that rule really carefully. We can see this on ground stroke when we want to hit the ball on the race. Imagine you receive a lob and the ball bounced like this, and the rebound will be like that. You want to do this, but the ball bounces like that. So you can decide to approach and take the ball on the rise if you want it. But it's exactly the same concept than the volley. The ball leaves the ground very vertically, and it will tend to bounce up in your racket. This requires a very high level of coordination to center that ball in your racket, because the ball bounces vertically, but your racket swing moving horizontally. It is strongly suggested to avoid excessive acceleration due to the difficulty of timing. Having a smooth and stable movement will facilitate timing without having too much exaggerated wrist movement. Now, let's talk about distance. You have to know those distances when you are at the baseline. A little bit of geometry on the court will have no secrets for you. Using the hypotenuse calculation, and we realize that the cross court will be a little bit different depending where you are on the court. In addition, if you're at different places on the court, you will not have the same leeway depending where you are. Your space will shrink as you enter into the court. And it will be expanded if you are further back, depending where you want to play on the court too. Distance equation. Distance does not exist by itself. It's a result of three balls control. We can therefore vary the distance either by changing the height, the speed, and the spin of the shot we will make. The spin will be a very specific capsule that we will see later. But one important thing to understand is the difference between the speed of the racket and the speed of the ball. The direction of the force vector applied will be decisive. Here is another concept of mathematics. It's how to calculate our rally average speed. The simple rule of three. It's take the number of strokes and the time, measure the distance for each stroke, and then make the time per second and make the calculation to establish the kilometers per hour. That could be useful to determine your risk during a shot. With that kind of mathematics, you could be good to know what could be your rally rate. This will give you a cue when you want to perform other shots from different places on the court. So the calculation is really simple because you need to know by heart where you hit the ball and what's the distance you aim. So you have to remember those numbers by heart. So make now a little bet on this situation. Let's see this point and try to guess on the average rally speed. The two players will hit 14 shots without counting serve and return in about 20 seconds. Notice the changes in rhythm of the two players, and especially the distance behind the line on each impact to determine a little bit the distance on every single shot. So what do you think is the speed of that point? Is it 50 kilometers per hour? Is it 60? Is it 70? The answer is B. So the players hit this. The ball covered, it's approximative, it's around 360 in 21 seconds. That gives you an idea of 61 kilometers average rate speed during that point. So that kind of exercise, it could be useful for you. If you do that on a constant basis, you say, okay, I can count on that kind of pace for my game. That gives you a margin of security when you play points. So now make a little summary of what we just did. We just saw. It will be possible to hit really hard if the ball is above the net and if you have a good mechanic. You have to respect the angle of ball received. You need to respect the ball location to apply the appropriate speed. And by knowing your average of rally pace, that will help you to better manage your risk during a match. Hopefully, this presentation on Science Law will help you to make your good decision in the game. You can send me your emails if you have any question. Thank you, and see you soon for our next capsule.